Compute the following limits. You can see that x squared minus 7x plus 10 in the denominator can be factored as x minus 5 times x minus 2. And the top one, I don't think you can factor this. There is no, if you multiply 2 and 1, that's 2. And if you think about the middle number 6, you're really trying to find two numbers that multiply to 2 and add to 6. And there aren't any numbers that does that, so the top cannot be factored. And actually, if you plug in 5 on the top, because it's all added, it's non-zero. So this is what's going to happen if you try to plug in 5. If you plug in 5 in the denominator, you get 5 minus 5, 5 minus 2 in the denominator, because the bottom is same as this. Whereas top is 2 times 5 squared plus 6x, 6 times 5 plus 1. And what's that? 25, 50, 30, 80, 81 on the top, whereas 5 minus 5 is 0. So you end up with a limit that looks like a non-zero number divided by 0. In that case, the limit does not exist. Now, however, there are a few more things I want to tell you. It's important that you figure out whether this is 0 plus or 0 minus or both. Because if it's 0 plus, then this will go to positive infinity, and this would be going to, the second one, 81 over 0 minus, would go to negative infinity. And if it's both, I'll tell you what this last case means. Okay, so here's what's happening. If you take limit x going to 5 plus, then the denominator will have 5 plus minus 5 and 5 plus minus 2 over 81, right? So this case will be that, and this will be 0 plus. It'll be 5 plus means something that's slightly bigger than 5. So if you subtract 5 from it, you still have something that's slightly bigger than 0. This is still something positive, right? 3, and then this is 81. So overall, you're going to get positive divided by positive, which is positive, and it also goes to positive infinity. On the other hand, if you take limit x going to 5 minus, 5 minus minus 5, 5 minus minus 2, 81, this is going to give you like 0 minus times 3 and then 81. So that's going to give you negative infinity. Now, since limit of x going to 5 means two things, limit x is sent to 5 minus and also limit x going to 5 plus. If they both yield plus infinity, for example, in that case you really have to write your answer as positive infinity, not d and e. However, and also if they're both negative, then you would also write negative infinity. But if one side goes to negative infinity, like our case, and the other side goes to positive infinity, then you can't say it converges to either plus infinity or negative infinity, so the only possible answer does not exist. Now let me put one more similar question here. You may have a case where after factoring the denominator and also, sorry, this is 10, also factoring the top, say 2x minus 10, if you factor this, you may see something like x minus 5, x minus 2, and then 2 times x minus 5, so that after factoring top and bottom, these two things cancel, and then only after that, when you plug in 5, you get 2 over 5 minus 2, which is 2 over 3. So this is another related question, and this time it gave us a finite number as a limit because both top and bottom had the factor of x minus 5. Here, the top could not be factored. So whenever you have a question where the bottom does factor by x minus 5, but the top doesn't have that same x minus 5, then taking x going to 5 would lead to does not exist, or positive infinity or negative infinity as your answer. For the second question, we have a piecewise function. And as I said, remember that x going to 1 means two things: limit x going to 1 minus and limit x going to 1 plus. If they both give you the same result, then whatever that result is the answer for this question. If they give you different answer, then you have to write does not exist. Okay, so let's try this out. Now, when your x is 1 minus, that means it's slightly less than 1. It falls into this first case. So we have to use limit x going to 1 minus of 2x plus 3. And then you plug in 1, which gives you 5. Okay. All right. How about this one? If your x is slightly bigger than 1, then it falls into this case where limit x going to 1 plus, that means you have to use this as your definition. Then when you plug in 1 plus 4, that's equal to 5. Since they're equal, therefore the answer is 5. Now, what may confuse you a little bit is that the actual value of f at 1 is 6. So while you do have the limit x going to 1 of f of x is 5, it's different from the value of f1 at 6. Such an example is like you have a limit, but then the value is in a different place. So that this is the case that you're seeing. You may have a limit, a function whose limit is defined. The limit does exist as a finite number, but it doesn't equal to the actual value. In this case, we say f of x is not continuous at x equals to 1. Keep in mind if the value of the function doesn't exist or the limit does not exist, that's also the case where it's not continuous. Being continuous means that the limit exists, the value exists, and they also agree. So it's actually like 3 conditions that has to be satisfied in order for some function to be continuous at a point. Okay, now we have another seemingly similar question, but notice that x is taken to negative infinity. When x is taken to positive infinity or negative infinity, you have to take a different strategy. You no longer try to factor the denominator or the numerator because it does nothing for this question. Instead, the standard way to solve this would be to divide the top and bottom by the highest order of the denominator. So the highest order is x squared, right? So you divide by x squared from the top, and also x squared plus 5x minus 24. You also divide this by the top. Okay. Then this gives you, let's see, negative infinity. This gives you 2 minus 1 over x minus 15 over x squared. And then x squared divided by x squared is 1. 5x divided by x squared. 5x divided by x squared, that's 5x over x times x. So these two cancel, and then you get 5 over x, right? So you get 5 over x, and then negative 24 is also divided by x squared. Okay, now you're sending x to negative infinity. Let's see, what is negative 1 over, when you plug in negative infinity into x, what is this? This is 1 divided by a very, very large quantity. Well, you can make this a positive by negative is positive. You have 1 divided by a tremendously large quantity, so that would be giving you 0. Same thing over here. You divide 15 by infinity, 5 by something infinity, 24 by infinity. So all these things disappear to 0, and you end up with 2 over 1. So the answer is 2 over 1. Compute the following derivatives. Now let's remember the formula for derivatives, which we call the power rule. Power rule says when you differentiate, this n comes down and you have to subtract 1 off the exponent. And this d dx simply means differentiate. It's just another symbol for derivatives. So this question just asks you to differentiate using this power rule. Okay, 7 times 9 comes down, and you subtract 1 off of 9, which is 8, plus 4 comes down. 4 times 6 is 24, x cubed. 2 comes down. 2 times 11 is 22. And then another thing is x prime is 1. Any constant prime is 0. So using that, you get negative 3, x differentiates to 1, so you just get negative 3, and 5 when you differentiate 0. So 7 times 9 is 63, x to the 8th plus 24, x cubed minus 22x minus 3. Okay, so this time we have a slightly different form. I guess this last one you'll need to use the chain rule. For these ones, you want to change them so that they look like x to some power. Okay, so let's first think about what x squared over x seventh means. Well, this means top is x times x, whereas bottom is like x times x times x times x times x times x times x. So when two of them cancel away, then what you're left with is 1 over x to the 5th power, right? And which is same as x to the negative 5 power. What about 4th root of x to the 5th? Well, 4th root is same as 1/4, and therefore this is same as 5 over 4. Okay, using these, now we can rewrite this question here as the derivative of 3 times x to the negative 5 minus x to the 5 over 4 plus e to the 3x squared. And then you're trying to differentiate this. Okay, by the way, let me also talk about the chain rule. Chain rule says if you have some nested function inside the exponential function, when you differentiate this, you treat f of x as if it's just x. What's the derivative of e to the x? It's the same thing, right? E to the x. But then the chain rule says, since you didn't do anything for this f, that has to be copied down here. You make a copy of it down here, and you differentiate that inside function. So that's the chain rule that we're going to apply for this. Okay. So let's now proceed to calculate. The power rule for this says negative 5 should come down, be multiplied to 3, which is negative 15, and then x. You have negative 5 minus 1, which is negative 6. 5 over 4 comes down, and then you subtract 1, which is 1/4. And then this last one, we use this formula, which says just copy what you have, e to the 3x squared, but then attach to it the derivative of 3x squared. So that's going to be negative 15 x to the negative 6 minus 5 over 4 x to the 1/4 plus derivative is 6x times e to the 3x squared. Okay, so for these 5 to the x prime, well, the formula for a to the x prime is a to the x ln of a. So using this formula, you know that 5x prime is 5 to the x ln of 5. And therefore, when we have, and also log of x prime is 1 over x. You have to know these formulas, okay? Yeah, I guess just one more in addition to this should be this formula. So you have to know these three formulas. Therefore, when you differentiate this, it's going to be 5 to the x ln of 5 minus ln of x differentiates to 1 over x. X to the 5th, 5 comes down, and you subtract 1 off of 5, so that's what it is. Now, this next part has to do with the product rule. Product rule says that when you have multiplication of two things, you're not allowed to differentiate this and that at the same time. You have to hold off differentiating one of them. Okay, so you have to hold off differentiating one of them. So we only differentiate the first one, we hold off differentiating the second one, just make a copy of it, and then plus e to the x, and we have to differentiate the second one. Okay. The most common mistake here is to just say, oh, this is the derivative of this times the derivative of this. Then it will be given no points. It will be a very bad answer. Okay, so when you have a product, make sure you're applying the product rule properly. We know that e to the x differentiates to e to the x, and then x squared differentiates to 2x, 3x differentiates to 3. Okay. Now this one, you need the quotient rule, which says f of x over g of x prime is f prime of x g of x minus f of x g prime of x over g of x squared. Okay. And again, when you have a division, you're not allowed to differentiate top and bottom at the same time. That will give you a nonsense answer. You should always use this quotient rule. And another common mistake that people make when they do the quotient rule is they switch these two. If you switch these two, you get an overall negative. Your answer will be off by a negative, so you have to be careful. Now, if you're ever in doubt of which one comes first, I guess it's good to just have this one memorized. 1 over x prime is negative 1 over x squared, which, by the way, appears many times by itself, so you should just memorize it. And just try to see if your quotient rule applied to this fraction does give you this right side. So during the exam, if you suddenly are not sure of which one comes first, just test on this one. Okay. Alright, so now let's apply this. It says x squared plus 4x minus 3 prime times x plus 2 minus x squared plus 4x minus 3 times x plus 2 prime. And then you have x plus 2 squared in the denominator, which gives you 2x plus 4, x plus 2, minus x squared plus 4x minus 3, x plus 2 prime is 1, and then you have x plus 2 squared. You should simplify the top one by foiling. 2x times x is 2x squared, 2x times 2 is 4x, 4 times x is 4x, and 4 times 2 is 8, minus x squared minus 4x plus 3, all over x plus 2 squared. 2x squared minus x squared is x squared. 4x and negative 4x would cancel, and you're left with 1 4x, and then 8 plus 3 would be 11 over x plus 2 squared. So that's the final answer. Compute the following integrals. You have you now have to use the following formula. Whenever you have integral of x to some power, you're supposed to add 1 to the exponent and put the reciprocal of this number in front. Okay, and for the other ones, you also have to know e to the x dx equals to e to the x, and integral of x to the negative 1 dx is ln of x plus c. I forgot to put plus c. Always put plus c for these integrals. Okay. Now, you may have noticed that this one looks exactly like this one with n equals to negative 1. What it means is that this formula should not be used when n is equal to negative 1. So only when n is not equal to negative 1 you use this. If n is equal to negative 1, you're going to use this one. Okay, so let's apply these formulas to the question. You have 4 times x to the 6th. I mean, all I want to do is I want to change this one. Minus 7. X to cube root is the same as 1/3 power, right? And then, and another thing, 6 integrates to 6x, which should be obvious for many people, but if that's not obvious to you, then another way to think about it is to rewrite 6 as 6 times x to the 0th power, because anything to the 0th power is 1, and we can still apply this formula for it. Okay, now let's just apply these formulas and see what we get. You're supposed to add 1 to 6, which gives you 7, and put the reciprocal, that's 1/7. So it's 4 times 1/7. You're supposed to add 1 to 1/3, which is 4/3, and then you have to put the reciprocal of 4/3, which is 3/4. Notice that I said reciprocal instead of saying 1/n plus 1, because this formula is kind of hard to use. It's better to understand this as add 1 and put the reciprocal. Okay, so we add 1 and put the reciprocal in front, minus 7 times, and then e to the x is e to the x, because e to the x differentiates to e to the x, and then finally 6, and then when you integrate x to the 0th power, you have to add 1 to 0, which is 1, x to the 1st power, and the reciprocal is 1/1, so we don't write either one of those, because x by itself means x to the 1st power, and dividing by 1 doesn't do anything at all. Okay, and once you're done with all the integrals, make sure you put this plus c, and after we simplify, that's the answer. 7 times 3 is 21/4, plus 9 e to the x minus 6x plus c. Now, because derivatives are not to be done by each element when you have a division, when it comes to integration, you're not supposed to integrate the top and bottom separately. In fact, if you just integrate the top and integrate the bottom separately and write that as your answer, you'll get 0 credit. It'll be very bad. So don't ever make that mistake. I really want you to remember that when you have a fraction, do not integrate top and bottom separately. Same goes for multiplication. If you have x to the 6th times 2x to the 5th minus 7x cubed, do not integrate these separately. That will result in 0 credit. Okay, very important. All right, so first of all, what your goal would be to actually write these into a non-fraction, because you're not taught on how to handle fractions. Handling fractions and multiplication is much harder, and therefore when you take calculus the next class, you're going to learn it there, but not in here. Okay, so you have 2x to the 5 over x to the 6. What I'm doing is I'm splitting the fraction into 2. See, these have common denominators, so if you put them together, you get back this one. So I'm doing the opposite of putting two fractions together. I'm splitting them. And then the rule is that you do 5 minus 6, which is -1. So this thing simplifies to -1. 3 minus 6, that's -3. So this is what you're integrating. Remember, x to the -1 integrates to what? It integrates to log. And what does this one integrate to? That's if you add 1, that's -2, and put the reciprocal, it's -1 over -2. Oh, there's one slight thing that I may not have clearly wrote down. For some reason, this formula here should be written as log of absolute value of x. Okay, and this one should also have that. Okay. It's a little time consuming to explain why that it needs to be there, but just remember this, okay? Alright, now we have to put plus c, and we're almost done. We now have 2 ln of absolute value of x minus minus plus 7 over 2, so it's plus 7 over 2 x -2 plus c. Let me, as a demonstration, show you what you should do when you have a multiplication instead. And this time you also use some algebraic manipulation to change these into terms that do not involve multiplication. So x to the 6th times x to the 5th, that's x to the 11th, right? X to the 6th times x to the 3rd is x to the 9th. So it's minus that. So if your question was this, then you want to distribute them so you have two terms. And now you can just integrate term by term. So x to 11, you add 1 to 11, that's 12. Reciprocal of 12 is 1 over 12. You add 1 to 9, that's 10. Reciprocal of 10 is what you put. And then plus c, and then I will reduce 2 over 12 as 1 over 6 x to the 12 minus 7 over 10 x to the 10 plus c. Okay, this is something we call definite integrals. Definite integrals mean that you have 6x squared minus 4x plus 3. You integrate this after you, the way you do definite integrals is you find the antiderivative first. So 6x squared times, well, let's see, you add 1 to the exponent, which is 3, put the reciprocal, so 6 over 3, minus, and then you add 1 to the exponent, with, see, x by itself is x to the first power, and plus 1, that's 2, and then put the reciprocal, so it's 4 over 2, and then 3 integrates to 3x. So once you found the antiderivative, then the definite integral says you have to plug in the endpoints and subtract. Okay, so 2 goes in here, so 6 over 3, 2 cubed, minus 4 over 2, 2 squared, plus 3 times 2 minus 6 over 3, negative 1 cubed, minus 4 over 2, negative 1 squared, plus 3 times negative 1. And then that's what? This is 2. 2 times 8 is 16. That's also 2, so that's minus 8. 3 times 2 is 6. Minus negative 2, 1, negative 2, and then minus 3. So let's see what we have. We now have 16 minus 8 is 8. 8 plus 6 is 14. That's negative 7, so it's plus 7. So overall, it's going to be 21. So that's what definite integral is. The meaning of this definite integral is something called net area. You don't have to know that for now. You just have to remember that once you get the antiderivative, then you plug in the endpoints and subtract. Okay, we have g of x, x cubed plus 6x squared minus 63x plus 11. Answer the following questions. Okay, find where gx is increasing and where it is decreasing. Now, a function is increasing if its derivative is positive, and a function is decreasing if its derivative is negative. So you should differentiate. When you are being asked increasing or decreasing, immediately you should calculate g prime. Look at the next question. It says concave up or down. A function is concave up if its second derivative is positive, and it's concave down if its second derivative is negative. So immediately when you see this concave up or down, you should find out the second derivative. Okay, the derivative is 3 comes down, subtract 1, 3x squared, subtract 1, that's 6 times 2, or 12x. 63, x differentiates to 1, so it's minus 63. I see that everything is a multiple of 3, so let's factor out a 3. So x squared plus 4x minus 21. And 21 is 7 times negative 3, so you can further factor this as 3 times x minus plus 7 and minus 3. Okay, now draw the number line. When is this equal to 0? It's 0 when x plus 7 is 0, so x is negative 7 here, and x is 3 here. Those are the two places where g prime is 0, negative 7 and 3. And therefore, once you have those points, you want to pick test points, 0 here, and then point over here, and then another one here, negative 8 here, and plug them in to figure out the size in each one of them. g prime of -8. Actually, it's easier to plug it into the factored form than the original one. If you plug in -8, let's see, g prime of -8 would be 3 times -8 plus 7 will be -1, and -8 minus 3 is -11. So as you can see, everything is when you multiply everything, that's positive 33. Okay, so it's positive here. If it's positive on this sample point, that means it's positive everywhere until you reach this point where it's 0. Now let's plug in 0. When you plug in 0, then it's easier to plug it in here because 0, 0 at, I mean, g prime of x is this, which is equal to this. So it doesn't matter which one you use, but I would like to use this one because if you plug in 0, that's gone, and you just get -63 immediately. So it's a lot convenient. And all we care is that it's a negative value, so we put minus here. When you plug in 4, again, we plug it in here. G prime of 4 gives you 3 times 4 plus 7 is positive 11. 4 minus 3 is 1, so you get positive 33, and we get plus plus here. Okay, so once we have used all the sample points to determine the sign of g prime in each of these subintervals, now we are ready to draw a conclusion. Whenever g prime is positive, we know that g of x is increasing. So we can say g of x is increasing on -infinity until you reach -7, and then 3 until infinity. Those are the places where g prime is positive. And also see that g prime is negative between -7 to 3. So we can say g of x is decreasing on -7 to 3. Okay, now let's find the second derivative. Second derivative is 6x plus 12. That's nothing. And when is this equal to 0? This is 0 when 6x plus 12 is equal to 0, and 6x is -12, and x is equal to -2. So you have this single point where g double prime is equal to 0. And again, you want to pick a test point. I'll put 0 and -3 to determine the sign of g double prime. When you plug in 0 here, 6 times 0 plus 12 is positive, so we know that it's plus over here. And then when you plug in -3, or -3 times 6 is -18, plus 12 is -6, so you know that it's negative everywhere here. And then a helpful picture to remember which one's which is to say if the second derivative is positive, it's a concave up thing, and if that second derivative is negative, then it's concave down. So you can say that concave up, which is like this, is on this interval here, -2 to infinity, and then concave down, which is like that, on -infinity to -2. Sketch the graph of h of x below using the following information. Okay, so these tell you what points it has to be passing through. So it has to be -2, 1, -1, 3, 0, 0, 1, -2, and 2, 2. So these are the points that the graph must pass through. And then we also know that at x equals to -1 and x equal to 1, you get h prime equal to 0. So that means these 2 points right here are possible places for relative extrema. Okay, all it here is saying is that it has a horizontal tangent, but if it has a horizontal tangent, then there's a high possibility that it could be a relative max or relative min. Another thing is if h double prime is equal to 0, that means those points could be points of inflection. So these are the points. These could be points of inflection. I'm being extra careful saying that they could be, because there's some strange cases where even though h double prime is 0, it's not, the concavity doesn't change before and after. Hopefully it's not the case here, but it could happen. Okay, now let's see. Right. So look at D. H prime is positive on negative infinity to negative 1 and 1 to infinity, and H prime is less than 0 from negative 1 to 1. So let's try to draw a picture and see what it means. So you have negative 1 and 1, and H prime is positive here, and also here. And then H prime is negative here. So what does that mean? That means the function is increasing and then decreasing and increasing. So that means this is a relative max and this is a relative min. Okay. All right. For this one here, we have negative 2, 0, and 2. Let's translate what this means. H double prime is positive on here and also here. Also, H double prime is negative in here and also here. Now, we do see that there's a change in concavity before and after these points. So these are all inflection points. So these are all inflection points. Okay. In very rare cases, you may have plus 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 and it might hit 0 and then plus plus again. In that case, those are not inflection points. Then we have limit of h going to negative infinity and positive infinity. These are what we call horizontal asymptotes. Okay. If you're curious to know what gives you vertical asymptotes? Vertical asymptotes happen if you have a limit that's like x going to x, a certain number, 0 plus or something, or let's say 9 plus, whatever. And if you had the function giving you positive infinity or negative infinity, in that case you will have x equals to 9, a vertical asymptote. So those are the cases where you have a vertical asymptote. Here you don't have anything like that. We only have horizontal asymptotes. These limits tell you what happens when x is going to the far away in the right direction and also to the left direction. So it's about what's happening as you go left or right. So these are about horizontal asymptotes. Alright, so let's try to draw this picture. First, place these points. I need let's see, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4, 1, 2, 3, and 4. Negative 2, 1 would be this point here. Negative 1, 3 would be here. 0, 0 is here. 1, negative 2 would be here. And then 2, 2 is over here. Before you include these considerations, try to put those horizontal asymptotes. So horizontal asymptotes as you go on the left side is negative 1. So as you go left, you need this horizontal asymptote. As you go right, you need this horizontal asymptote. It has to go through towards this point. Alright. Now, if we only consider just the increasing and decreasing and increasing, this is the type of graph we would get. We would get something like it's increasing and then decreasing and then increasing again. Right? Now, if we also consider this this asymptotes, we'll probably have to bend it here so that it gets closer and closer to positive 4 as you go right, and it gets closer and closer to negative 4 if you go left. Now, what about the actual graph? Well, actual graph, I'm going to use a purple here. Actual graph has to be curved. It can't just turn sharply like this. It has to be curved. And because the graph is concave down, remember here from -2 to 0, it's concave down like that, right? It has to have this shape. And also from 0 to 2, it has to, from 0 to 2, it has have a concave up shape. And then after 2, it has to be increasing and concave down. So it should be like this graph. See, if you have concave down and also increasing means only this half of the concave down. So this will be when you have increasing and concave down. Okay, that's why you have this graph. Same thing over here. If you have increasing concave up, you would have this graph over here. So that final graph here would be the answer. A wire 28 inches long is cut into 2 unequal pieces. One piece is bent into a square, the other is bent into a rectangle, the base of which is 3 times its height. How long should each of the 2 pieces of wire be to minimize the sum of the areas of the square and the rectangle? Use calculus to answer the question. The drawing below will help you get started. Okay, so this picture here seems to indicate that you have x plus x plus x plus x plus y plus 3y plus y plus 3y equal to 28 inches. All right, how many x's are there now? Then that's 4x, and then 1 plus 3 plus 1 plus 3, that's 8y. They have to add up to 28. Let's simplify this. I can divide everything by 4, so x plus 2y should equal to 7. So that's the relationship between x and y. Now, since x and y cannot be negative, the least value x can be a 0, and the max value that x could be is 7, because when x hits 7, then y is 0. If x goes beyond 7, then y becomes negative. So that's something that you would like to have. Okay, now the area for the first one is x squared. The area for the second one is 3y squared. And you have the sum of the areas that you want to minimize. So your goal, or the target, your target function, is the sum of the areas, x squared plus 3y squared. Now it said to use calculus to answer the question, so we must involve derivative somewhere. Any question that doesn't have the derivative won't be worth anything. Make sure you're using derivative somewhere. And the problem with that is we don't know how to differentiate this because it has 2 variables. We have to reduce this function into a function of a single variable by using this here. Okay, you can either choose to solve for x or solve for y. I'll try to solve for x because I have the minimum and maximum value for x, but you can also solve this by solving for y. Okay, so x, I'll try to solve this for y because I want the resulting function to be a function of x. Okay, but you can certainly try to solve this for x and write something here. Okay, so we have 2y equals to, if you subtract x both sides, I have 2y equals to 7 minus x, and therefore y is 7 minus x over 2. When this goes in here, now a is equal to x squared plus 3 times 7 minus x over 2 squared, which is x squared plus 3 times 7 squared is 49, x squared is x squared, and then you have to double the product. If you FOIL this, you end up with some strange term, which is twice of 7 times negative x, which is negative 14x. Okay, if you're not sure why you have this negative 14x, take your time to do this multiplication, 7 minus x times 7 minus x. And you're going to see when you FOIL this, you do get negative 14x. A lot of mistakes are due to forgetting this negative 14x. Okay, and then 2 squared is 4. Now let's use common denominators so that this is 4x squared over 4. 3 times 49 is 100, let's see, 150, 147. And then you have 3 times x squared, which is plus 3x squared. And then 3 times negative 14 is negative 52. No, 42, sorry, 42x, which simplifies, if you combine these two, you have 7x squared minus 42x plus 147. Okay, so now you see that your goal is to to find the minimum of this value, right? One thing that you could say is that since it's a quadratic function with positive 7, we know that the graph of a would be like a parabola like that. So it's going to have a minimum somewhere, and the maximum would be either when x is 0 or x is 7. Remember, x value is between 0 to 7, so the maximum will happen either here or there. That means we just have to figure out when you have a prime is 0. Okay, but usually you have to justify your argument. So let me show you also how to justify your argument. Okay, so first we have a prime equals to, if you differentiate this, 7x squared, 2 comes down times 7 is 14x minus 42, and 147, that's a constant, so that goes away. And I didn't do anything about this 4 because this division by 4 is nothing more than 1/4 times this entire thing, so it's a constant multiple. Constant multiples, you don't have to do anything. Alright, when is this equal to 0? That's equal to 0 when well, let's simplify this by dividing top and bottom by 2. So this is 7x, and then this is minus 21 over 2, and a prime is equal to 0 when x is equal to 21 divided by 7, which is 3. Okay, now that we know that a prime is 0 at 3, just pick some test points before and after 3. So plug in something like 4 here, and then 2 here, plug it into a prime. If you plug that in here, 2 times 7 is 14, 14 minus 20 is negative 7, so it's negative here. And also at 4, if you plug in 4 into x, 4 times 7 is 28, 28 minus 21 is positive 7, so it's plus here. So we know that it's negative before and plus there, so we know that the function a decreases and then increases after 3. So at 3 you have the minimum. And what was the question again? You always have to check for the question. Sometimes they want the minimum area, sometimes they want the minimum value of x and y. Okay, so how long should each of the 2 pieces of wire be to minimize? Okay, so because we know it's minimum, we know that x has to be 3, and when 3 inches. And when you plug in 3 in here and solve for y, you get y equals to 2, right? See, if you plug in 3 here, 7 minus 3 is 4, 4 divided by 2 is 2, so y has to be 2 inches. Okay, so that's how you solve this question. Find the formula for dy dx for this curve. Okay, so we have to differentiate both sides using implicit differentiation. And then if you have a product, remember y is implicitly a function of x, so when you see this, you should treat this as a product of 2 functions of x, which means you have to use the product rule. So let's apply the product rule, which says differentiate one of them while hold off differentiating the other part of the product, plus differentiate the other part that you didn't differentiate and hold off differentiating the other one you already differentiated. Okay, same thing goes here. You're trying to differentiate y squared by x. What does that mean? You have to use, so when you differentiate y squared by x, since y is a function of x, inside the square function, that means you need to use the chain rule for this. Okay, we'll think about how to do that a little later. This one, again, the same thing. You have to differentiate the first one while holding off the derivative in the second one, and then leave the x as it is, but then differentiate the second one. The last one, you're differentiating a constant by x, so it's 0. So that's what you have. X cubed, when you differentiate this, is 3x squared y. This just means dy dx times x cubed. Now, let's think about this one. You can, instead of differentiating by x, you can differentiate by y. But there's a cost. These two are not the same. How do you make these two equal? You put dy over dx attached to it so that when you see this, it looks like dy cancels and you recover the original thing, right? This is actually called the Leibniz form of the chain rule. And you can do the same thing for, well, ddx of x is 1, so it's just y cubed, 1 times y cubed. You can do the same thing for here. You can differentiate by y and multiply dy and then divide by dx. Okay, now let's further simplify. 3x squared y plus x cubed times dy dx. I just switched these two places. And then over here, y squared differentiated by y is 2y, so it's 2y dy dx plus y cubed plus y cubed differentiated by y gives you 3y squared, so it's 3xy squared dy dx. Now the trick is to move to one side everything that has dy dx, and then move to the other side everything that doesn't have dy dx. So y cubed, let's move it over to the left, so you have 3x squared y minus y cubed equal to 2y plus 3xy squared minus x cubed, all of them times dy dx. That's what you have on the right side. And you finally solve it by dividing, so you have dy dx equal to 3x squared y minus y cubed on the top, whereas on the bottom you have 2y plus 3xy squared minus x cubed. So that's like the standard way. Maybe let me show you another way I like to do it. I think this is a little shorter, but it requires you to be more attentive of what's going on. So you're differentiating x cubed y, right? So you differentiate x cubed, which is 3x squared, times y plus, and then you differentiate the second one, so you're differentiating y, which is y prime. That's what you get on the left side. Y squared, when you differentiate by x, remember you have to use the chain rule, so you differentiate y squared as a function of y, which is 2y, and then since y is a nested function, bring it outside and differentiate. So 2y y prime is what you get if you use the chain rule, the usual one that you're used to. And then over here, if you differentiate x, it's just 1, so it's y cubed, and then plus, when you differentiate y cubed, so x times y cubed, it's 3y squared, but then since y is a nested function, bring that y outside and differentiate. Of course, plus 2 should go away because you're differentiating a constant. And then move y cubed to the other side and bring it over here, so you have 3x squared y minus y cubed, 2y y prime plus x, or 3xy squared y prime minus x cubed y prime, and then you factor the y prime out. And then finally you divide this by this to solve for y prime, which will give you the exact same answer as that one. Okay. So either way, you're going to get that answer. Now, you're trying to find the equation of the tangent line. Whenever you're being asked the equation of the tangent line, it's good to write down the formula, the point slope form. And this m, which is a slope, is obtained by using this derivative. And the most common mistake is to think that this itself is the derivative, and that's not right. Only when you evaluate this function at the given point, -1, 2, you actually have the slope. So m would be this 3x squared y minus y cubed over 2y plus 3xy squared minus x cubed, evaluated at x equals to -1 and y equals to 2 at -1, 2. So if you plug that in, that's -1 squared is +1, and times 2, so that's 6. If you plug in 2, that's 2 to the cube, that's 8, over 2y, 2 times 2 is 4, 3 times -1, -3, times 4, so it's -12, and then -1 cubed, that's negative of -1, which gives you -2 on top, and that's -8 plus 1, -7 on the bottom. Let me just make sure that's -8, -7. Okay, so that's 2 over 7. 2 over 7 is your slope, and then since it passes through 2 and -1, you put 2 in here and 1 there, so you have y minus 2 equals to 2 over 7 x minus -1. Now, since it said you have to put your answer in y equals to mx plus b form, let's do that by multiplying this out. So you have y minus 2 equals to 2 over 7 x. -1 is +1 times 2 over 7 is plus 2 over 7, and then finally add 2, you get y equals to 2 over 7x. 2 is 14 over 7, right? So when you add 14 over 7 plus 2 over 7, then you're going to get 16 over 7. Number 10, 26-foot ladder is leaning against the side of a building. So here's a building, here's a 26-foot. And then the top of the ladder is sliding down, going down, and at 2 feet per second. How fast is the foot of the ladder moving away from the building when the top of the ladder is 24 feet above the ground? Use calculus to answer this question. All right, so you're given a rate of change of one thing, and then you're being asked how fast, in other words, the rate of change of another thing. So this is a related rates question. Now, related rates question should be solved first by drawing a simplified picture, and 26, and you have to somehow talk about rate of change of this, so I'm going to put y here and then x here. And if your simplified picture happens to be a right triangle, then just go for the Pythagorean theorem. If you have two triangles, then in some cases you may have to put similar triangles, so you may have to work with ratios. But if you only have one single right triangle, then what else can it be? It has to be the Pythagorean theorem. So just write Pythagorean theorem once you have a right triangle. Then let's try to write down what this means. The top of the ladder is sliding down the side of the building at a constant speed of 2 feet per second. So if this is coming down, this length y will be decreasing. So dy dt would be -2. And then what is the question being asked? It's asking how fast, what's the rate of change of dt, dx dt, how fast is the foot of the ladder with respect to the building its speed is measured by change of this length x. So you should write dx dt as how fast is all this, okay? And then when the top of the ladder is 24 feet, that means when y is equals to 24, what is this value? That's the question, right? Okay. One of the things that you have to be careful when solving related rates question is when you see this word when or at or something like that, you should not plug this number into the given equation before differentiating. You're only going to consider this once you have the derivative, okay? So we have this equation which gives you the relationship between x and y. We want to differentiate this with respect to t before plugging in 24 into y. Okay, that's the important part. Okay, so let's differentiate this. X squared prime, y squared prime, 26 squared prime, but well, 26 squared, that's just a number, so that's going to give you 0. X squared prime, what's that? X is a function of t. X does change with respect to time, and this prime really means d dt, right? So when you differentiate this, you have to use the chain rule, which says differentiate it as a function of x, which gives you 2x, but then x has to be pulled out and you have to differentiate it. Same goes for y squared. You differentiate y squared as a function of y, which is 2y, and then differentiate y prime. Okay, where this x prime really means dt of x, and then y prime is d dt of y. Okay. Alright, so we have that, and since we know that dy dt is negative 2, we can apply it right here. So if 2x prime is negative 2y times y prime, but that's negative 2. I moved this over to the other side, and then I plugged in negative 2 there, so I have 2x prime equals to 4y. Divide by 2x both sides. So you have x prime equals to, after 4 divided by 2 is 2, so you have 2y over x. So we're almost there because we're looking for this dx dt, and we figured out that that's same as 2y over x. But it's asking me for dx dt when y is 24. Now when y is 24, if this length is 24, what is this length? If you plug in 24 here, if you do x squared plus 24 squared equals to 26 squared. By the way, we already had done the computation for the derivative, so now it doesn't hurt to plug in 24 into the equation, okay? If you solve this, you're going to find that x is equal to 10, okay? Use your calculator or something, so you get 10. So when dx dt, if you're looking for dx dt when y is 24, that means x would be 10. So you get 2 times 24 over 10, which is like 48 divided by 10, which is 4.8. And I believe the equation is, the unit is feet per second, so it's 4.8 feet per second. So that's how you solve this.